Hello everyone. In this video, I will discuss about AC/DC rectifier, single phase, half wave, control rectifier. Our load is resistor and inductor, and also we put freewheeling diode in between SCR and load. So on our circuit, we will divide it into a few sections. Okay, first is section 1, section 2, section 3. Okay, into 3 sections. Section 1 from 0 to alpha. Section 2 is from alpha to pi. Section 3 is from pi to 2 pi. Okay, let's start with the first section. Section 1 from 0 to alpha angle. Okay, here positive cycle. Positive cycle. Waveform will be positive. So positive terminal here, negative terminal at the bottom, arrow same as the input signal. So we know that current will flow from positive terminal to our SCR. Okay, at this section, okay, we know that the characteristic of SCR, to switch on the SCR, we need gate current inject to the gate terminal. So during 0 to alpha, the gate current is, we are not injecting the current yet. This one is, let's say, this is gate current. Okay, IG inject after alpha. So between 0 and alpha, there's no IG. IG equal to 0. So at that one is Vs greater than 0. I get equal to 0. So that means our SCR will be off. So sometimes we call forward blocking mode. Okay, off. Forward blocking mode. Okay, off. So current cannot flow. Current cannot flow. So when current cannot flow, I not equal to 0 ampere. So there is, when there is no current here. So that means there will be no voltage here. Okay, no voltage drop due to no current flow. So our output will be 0 volt. So we can say this is our output graph. So from 0 to alpha, 0 volt. Okay. And about we know that the characteristic of inductor is charging and discharging. However, during 0 to alpha, there is no current flow, so this inductor cannot charge. So I out equal to 0 due to off, SCR off. Okay, how about VT? Thyristor voltage. Okay, we're using KVL here. KVL V thyristor equal to V source minus V output. In this case, V output equal to 0, so that means V thyristor equal to V source equal to V M sin omega t. Okay, this one is sinusoidal. Sinusoidal Vm sin omega t. Okay, that means during 0 to alpha, the thyristor voltage is equal to input. So in this case, like this. Okay, voltage is so same. Okay, just follow the waveform of the input during 0 to alpha. Okay, next section is at this section from alpha to pi. Okay, from alpha to pi, positive cycle. Okay, at this time, we will inject the current. Ig is not equal to 0. That means we inject I gate to gate terminal. And also at this time, positive cycle means that Vs greater than 0. So what happens is our SCR will be on. Okay, when we inject the current to gate terminal, so SCR will be on, forward conducting mode. Okay, so let's do this first. Okay. Okay, during number 2, during section 2. Section 2, okay, so current with, okay, SCR will be on, short circuit, on. So current will flow from this terminal until the junction. Okay, current cannot flow here because this one is in reverse bias. So current with all the current will go to the output, go to the inductor, and go back to the source. Okay, when this current we call I out. When current go to the resistor, there will be VR equal to I times R, and VL will be equal to L di over dt. So this store energy. Our inductor will store energy. Okay, we know that this inductor can store energy. Okay, during positive cycle, okay, at this time V out is here. Okay, using KVL there. KVL V out equal to Vs minus Vt, the thyristor. Okay, V thyristor equal to 0 due to thyristor is on, thyristor short circuit. So V out will be equal to Vs equal to V max sine omega t. Okay, this one is a waveform of this part. So let me change the color. Okay, so it means that from alpha to pi, this waveform. This is input waveform from alpha to pi. So the output will be same as the input. Okay, output same as the input. Okay, will be like this. From alpha to pi. Okay, all the input go to the output. Okay, for current, we know that the inductor will charging here, charging due to I not enter inductor, so inductor will charging. Okay, inductor will charging from alpha to pi here. Okay. Okay. For the thyristor voltage, we know that at this time from alpha to pi, thyristor is switched on. So when thyristor switch on or short circuit, we know that for short circuit 0 volt. Okay, graph will be like this. That one is during second region, second phase. So now we go to third phase or negative cycle. So I need to erase first. Let me erase. Okay, third section is between between pi to 2 pi. Third section is between pi to 2 pi. Negative cycle. So our input is negative. Okay. Okay, during positive cycle, our inductor charge until from alpha to pi, the inductor charge. We know that the characteristic of inductor, it will charge during positive cycle when it receives current. Then during negative cycle, it will become current source. Discharge energy. Okay, it will discharge energy here. Okay, this one is V source. This one is from current from inductor. Okay, it will go here. Then the current go here. Okay, arrow of the diode and arrow of the current is same arrow. So that means this diode will be switch on. Feedback. Sorry, forward bias. So it will switch on. Short circuit. Forward bias, short circuit. Okay, so current will flow to here and go around here. So at VR, the energy will be dissipated. At energy here. So it will go here. Now here. Okay. At this time, okay, due to Vs is negative, less than 0. So I get this equal to 0. So that means SCR off. SCR off. Open circuit. Open circuit. Okay. Okay. The output. What is the output? Okay. At third region. Okay. We know that this one is short circuit. The diode is short circuit. So for short circuit, 0 volt. Okay, due to short circuit. Okay, you can see this one and this one parallel. So we know that for the parallel circuit, the voltage is same, equal. Voltage at this and this equal. So it means that this voltage equal to V out equal to V at diode. This diode is short circuit, so equal to 0 volt due to the FWD diode, the freewheeling diode is short circuit. Freewheeling diode short circuit 0 volt. So output will be same as freewheeling diode voltage. Freewheeling diode voltage is 0, so output will be 0 from pi to pi. Okay. Okay. And current, how about current? We know that this current will be discharge will be reduced due to there is no supply, so it just it will give current to R resistor, so it will reduce. So like this, or it can be like this. It can be more. It depends on the time, on discharging time, because we know that the discharging is equal to L di over dt. So it's time. So it depends on the time, like this or like this. So we can modify the time. We can change. We can select the suitable inductor to make our discharging time longer or less, short or longer time. So for this case, let's assume just like this. It will discharge until 2 pi. Okay. Okay. For thyristor voltage, we know that thyristor voltage is off. The thyristor is off. So by using KVL, thyristor voltage Vt equal to Vs minus Vout. We know that Vout equal to 0. Okay. So Vs Vm sine omega t. Okay, means that the thyristor, the output of thyristor is same as the input. Same as the input. So our input will be like this. sinusoidal from pi to 2 pi. How important this? So the output will be the thyristor voltage will be same as input voltage from pi to pi. Okay, that's all for third section of the waveform. So the next section just follow the previous one, repeating. Okay, that's all for waveform. So next we study the equation. We derive the equation, the related equation in this circuit. First, we check the average output. V out average is equal to area divided by period. Okay, area is this our output. Average output will be area under the curve. Area under the curve is here from alpha to pi. Okay, area under the curve here. Okay, period 1/2 so will be equal to 1 over 2 pi. We derive from alpha to pi Vm sine omega t d omega t. The integration there, so we will get Vm over 2 pi integrate alpha pi sine omega t d omega t. So this will be equal to Vm over 2 pi 1 plus cos alpha. This one is V average. Okay. I average, we just Vm over 2 pi divided by R. Okay, this is our R. So divide by R. Okay. The next is VRMS. Okay, root mean average square. Okay, VRMS will be equal to Vm sine omega t square d omega t. So we will get so change to identity 1 minus cos 2 omega t over 2 d omega t. So finally, when we solve this equation, VRMS will be equal to Vm over 2 1 minus alpha over pi plus sine 2 alpha divided by 2 pi. This is our VRMS. Okay. For power, we just power V RMS square over R. Okay. Okay. That one is the important parameter in a rectifier. So I think that's all for derivation of waveform and equation DC rectifier, single phase half wave control rectifier, resistor and inductor as a load, and we're using FWD, freewheeling diode. Okay, that's all. Thank you. Bye-bye.